Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so guys, this is the first lecture of condensed matter physics. Okay, so I am going to start condensed matter physics today. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so this is the first lecture of condensed matter physics. Okay, so I'll start now. As quantum mechanics is completed, so I have started condensed matter physics. Okay, so I will start with crystalline and non-crystalline solid. Okay, this is condensed matter physics. Condensed matter physics. Okay, condensed matter physics. Condensed matter physics. This is lecture 1. Okay, so I'll make a table. This is crystalline solid, crystalline and non-crystalline. Very important for NET. Okay, for NET exam, GATE, NT, PhD, and other physical exams, other exams related to physical science. Okay, so non-crystalline solid. Okay, so crystalline solid and non-crystalline solid. Okay, so crystalline solid is periodic. So you will get periodic arrangement in crystalline solid. Okay, so periodic arrangement. Periodic you will get periodic arrangements in the crystalline solid. Okay, so you will get periodicity. Okay, and for non-crystalline solid, irregular arrangement you will get. Okay, so periodic arrangement so you will get periodic arrangement in crystalline solid, and there will be irregular arrangement. So okay, so there wouldn't be any periodicity in non-crystalline solid. Okay, second is definite order. So crystalline solid have a definite order. Okay, so you'll get a definite order, definite shape. Okay, so definite order. Definite order, and this is, and for non-crystalline solid, no definite order. No definite order. So there wouldn't be any definite order in non-crystalline solid. Okay, and there will be definite order. You will see definite order in crystalline solid. Okay, next, so crystalline solid have sharp melting point. Okay, sharp melting point. Okay, so crystalline solid have sharp melting point, and they don't have. Okay, no sharp melting point. Okay, no sharp melting point. no sharp melting point, okay, in non-crystalline solid. Next, and you will find crystalline solid in they will be in stable state, okay, stable state, stable state. So they will be in stable state, or they have minimum energy. That is, stable state means they will be in their minimum energy, okay. So minimum energy, minimum energy, okay. You will get unstable. You will get non-crystalline solid in unstable state, okay. So unstable state. So unstable state. Next, so crystalline solid are an isotropic, okay, an isotropic, okay. Get an iso an isotropic. So the crystalline solid are an isotropic. This means they have different property in different direction, okay. So they are an isotropic, okay, different and they are isotropic, okay, isotropic. So non-crystalline solids are isotropic, means they have same property in all direction, but crystalline solid are anisotropic, means they have different property in different direction, okay. So I can write here in bracket different property in different direction, different property in different direction, okay, different property in different direction, okay. So this is the classification of crystalline solid and non-crystalline solid, okay. Next, single crystalline solid. Single crystalline solid. Single crystalline solid, okay. Single crystalline solid. So single crystalline solid like this, okay. This the arrangement of single crystalline solid is like this. Okay, so they are single crystalline solid. This is the arrangement of them. And poly, I'm just giving brief idea, then we'll proceed further. Okay, so then polycrystalline, which we have already studied in crystalline, non-crystalline solids. Okay, so it's polycrystalline, polycrystalline, polycrystalline solid, polycrystalline solid. Okay, so polycrystalline solid, the shape of the polycrystalline solid is like this. I'll show you. Okay. So you will get this type of arrangement in polycrystalline solid, okay, and these are called grains, okay, these are called grains, and these lines are called grain boundary, okay, grain boundary, grain boundary, okay. So these are grain boundaries and these are grains, these are called grains, okay. So you will get this type of arrangement in polycrystalline solid, okay, and in single crystalline solid you will get this type of arrangement, okay. Here in you get regular arrangement or periodic arrangement in crystalline solid, okay. So this is the single crystalline solid and this is the polycrystalline solid. So now we'll study crystal structure, okay. crystal structure. Crystal structure. So first we will study lattice. What is lattice? Okay, lattice. What is lattice? Okay. Okay. So lattice means periodic arrangement. Periodic arrangement. Periodic arrangement of imaginary point on space. Okay. Periodic arrangement of imaginary periodic arrangement of imaginary periodic arrangement of imaginary lattice point. Okay, lattice point. So it is periodic arrangement of imaginary lattice points. Okay, I'll show you here. So in 1D I'm just defining in very simple language so that you can understand quickly. Okay, so in 1D like this, these are imaginary points in this space, right? Imaginary point, imaginary lattice point. Okay, so in 1D or in 2D in 2D that is this is like this. Okay, okay, so this is the arrangement in 2D, guys. Okay, so in 2D these are the imaginary points in this space or imaginary lattice point in this space. Okay, so this is called lattice. Okay, now basis. Okay, basis now basis. Okay, so basis is group of atoms or molecule, that is the basis. Okay, group of atoms or molecule. So this is group of atoms or molecule. Group of atoms or molecule that is called basis. Okay, so now crystal structure. Okay, so these are imaginary point lattice points, that is lattice. Okay, plus basis are, that is atom, right? This is atom, basis, and this is lattice. Okay, and so if you put each atoms on individual lattice point, right, this forms the crystal structure. Okay, this forms the crystal. Okay, lattice plus basis equal to crystal. So if you put each atoms on each lattice point, right, that construct a crystal. Okay, crystal. So this is crystal structure, guys. Lattice plus basis equal to crystal. Okay, so bases are a group of atoms or group of molecules, and these are lattice are imaginary point in this space, imaginary lattice point. And if you put those each molecules on each lattice point, that forms the crystal structure. Okay, so lattice plus basis equal to crystal. Very simple, right? Now translational vector, translational vector, translational vector, that is T equal to n1a, okay, vector, right? n1a plus n2b plus n3c. Okay, so this is the translational vector, guys. Okay, next is unit cell. Next is unit cell. Unit cell. Unit cell. Next is unit cell. Next is unit cell. Okay, unit cell is, the definition of unit cell is the smallest unit of the crystal which on continuous repetition, okay, generates the whole crystal. Okay, so this is the smallest unit of the crystal, and if we repeat that crystal, that unit, that will generate the this crystal. Okay, complete crystal. So unit cell is smallest unit, smallest unit, smallest unit, smallest, smallest, smallest unit of the crystal, of the crystal, smallest unit of the crystal, of the crystal, which on continuous repetition, which on continuous, which on continuous repetition, continuous repetition, repetition, continuous repetition generates the whole crystal, the whole crystal, whole crystal. Okay, so the smallest unit of crystal, smallest unit of crystal which on continuous repetition generates the whole crystal. Okay, so that is called unit cell, and this is also called building basic building block. Okay, basic building block, basic building block, basic building block, basic building block. Okay, and now primitive unit cell. So this is the unit cell. Now primitive unit cell. Okay, primitive unit cell, primitive unit cell. Meanwhile, just let me check whether I'm audible or not. Okay. Building block. Yes, I'm audible, so I'll proceed further. So primitive unit cell, guys. Okay, primitive unit cell means who has effective number of atom is 1. Okay, so effective number of atom is 1, whose effective number of atom is 1. So effective number of atom equal to 1, or we can write in short NEFF. Okay, that is called effective number of atoms. NEFF is 1. That is called primitive unit cell. So I'll give example. Okay. Okay. So here you can take this square. Okay, square. So, and these are the atoms. So in 2D, this is a 2D structure, right? So it means the atom will be circle. Okay, and this is the atom, and there is, right. So we can see the angle between this is a square, right? The angle is so there is a square, and the corner of the square there is a circle. Okay, so if we see angle is 90 degrees, so effective number of atom, if you want to find, so this is going to be 90 upon total angle is 60, and the angle of this square that is, we can see 90-degree angle. Okay. Square makes 90-degree angle, right? So 90 upon 60 into 90 upon 60 90 upon 360, that 90 degree upon 360, it is going to be 1 by 4, right? So n effective for this structure, n effective is going to be n effective is going to be 4. There are 4 atom, right? There are 4 atom, and 1 upon 4 into 1 by 4, that is 1. So this structure is called unit. This is primitive cell. Okay, primitive unit cell. Okay, so this is primitive unit cell. Example of primitive unit cell means whose effective number is 1. Okay, n effective, the value of n effective is 1. So n effective is because there are 4 circle, right? 4 atom, you can say 4 circles, right? And first we'll find that angle, right? That circle, this makes square makes 90-degree angle, right? So 90 upon 36, 360, right? This is going to give value 1 by 4, and there are 4 atoms. Will multiply 4 by 1 by 4 this value, and we are getting 1. So the effective number of atom in this structure is 1. So this is the example of primitive unit cell. Okay, I'll give you another example. So here this is also a square. Okay, this is also a square, and there are 5 atoms. Okay, so 2D atoms are circle, guys. Okay, 2D, these are 2D atoms, these are circle. Okay, so there is one more atom, right? Okay, so here we'll find that angle, right? This is 90-degree upon 360, so this is going to be 1 by 4. So n effective is going to be 1 by 4 into 4, and there is one atom. There is one atom inside, right? Total number of atom in the unit cell, right? That is the effective number of atoms. So 1 by 4 plus 1 atom is already inside this, so this is going to be 2. So this is not a unit, this is a unit cell, but this is not a primitive unit cell, guys, because effective number is 2. Okay, so this is an example of non-primitive unit cell. Non-primitive unit cell. Okay, non-primitive unit cell. Non-primitive unit cell. Okay, well, this is about primitive cell and non-primitive unit cell. Next is, in 2D lattice, we'll study crystal structure and Brevis lattice. Okay, and the condition. Very important, guys. You can get questions from this. Okay, so this is crystal structure, 2D lattice. Okay, so we are talking about 2D lattice. 2D lattice. So lattice in 2D. Okay, 2D lattice. In 2D lattice, we are going to study crystal structure. crystal structure, and this is brevis lattice. brevis lattice and condition. Very important table, guys. You need to note down and you need to learn it. Okay, very important. So crystal structure, brevis lattice and condition. Okay, so you need to know the what are crystal structures in 2D and what are the brevis lattice and what is the condition for that. Okay, so first is oblique. Okay, oblique. First is oblique. Okay, oblique means like this, right? This is gamma. This is angle. Okay, gamma. So here brevis lattice for oblique is brevis lattice for oblique is oblique. Okay, oblique. This chart you need to know because you can be asked questions in the examination. Okay, so brevis lattice for crystal structure, this oblique crystal structure is oblique. Okay, and condition for this condition is A not equal to B. The side A will not be equal to B. Okay, side AB will not be equal to side A will not be equal to B. Okay, second, the angle will not be equal to 90. Okay, so this means gamma is angle. Okay, gamma not equal to 90. For being oblique structure, gamma shouldn't be 90 and side A should not be equal to B. Okay, and this is an oblique example of oblique. So and brevis lattice oblique. Okay, second is rectangular. Okay, rectangular. Okay, rectangular. So this is a rectangle, guys. Okay, so for rectangular there are two type of brevis lattice. Okay, so crystal structure is rectangular and brevis lattice for the rectangular crystal structure are two. Okay, the first is, I'll show you from it, that is this one. This one, rectangular primitive. Okay, rectangular primitive means whose effective for that an effective number of atom is 1. Okay, so that is rectangular right here. Rectangular, this is called a rectangular primitive. Okay, so rectangular primitive, okay. Second is this one. So this is rectangular centered. Okay, this is rectangular centered because there is a one atom. So for rectangular crystal lattice there are two types of brevis lattice. One is rectangular primitive and another is rectangular uh, centered. Okay, so rectangular centered. Okay, and condition for this rectangular is this one. Obviously A not equal to B, right? Side A and side B will not be equal to each other, right? And but value of gamma is 90 degree. For value of gamma is 90 degree. Okay, so for the oblique, sides are not equal, A not equal to B, and also the angle between the side is not 90 degree. But for rectangular structure, crystal structure, so there are two types of brevis lattice: rectangular primitive and rectangular centered. and for that a obviously it's a rectangle, that a not equal to b, but the angle gamma is 90 degree. Okay, this is the second one. The third is square. Third is square. Third is square. Third is square. Okay, so this is a square. Third crystal structure is square. Okay, third is square. Okay, and for that the brevis lattice is square. Brevis lattice is square, and obviously condition is a equal to b because it's a square, and gamma equal to 90 degree. Obviously all angles are 90 degree. These angles I'm talking about. Okay, 90 degree. So this is the so in 2D the crystal structures are oblique, rectangular, square, and there is one more. I'm going to write in next page. One more is brevis lattice. Okay, so crystal structure is hexagonal. Okay, hexagonal. Third, this is fourth. Okay, hexagonal. Okay, this is the hexagonal, guys. Okay, this is hexagonal, and brevis lattice is hexagonal. Okay, brevis lattice is hexagonal, and condition is obviously a equal to b for hexagonal, and gamma is going to be 120 degree for hexagonal. Okay, so angle is going to be 120 degree. Okay, okay, 120 degree. And if you have to find effective number, I'll show one thing. If you have to find effective number here for case of hexagonal, right? So this is going to be one atom here, one atom here, one atom here, one atom here, one atom. So effective number for hexagonal is going to be, that is, we know the angle, right? So this angle is 120 and total angle is 360. So we can write 120 upon 360. Okay, so this is going to be 1 by 3. Okay, so there are 6 atoms, so effective number is going to be, and effective is going to be, okay, and effective is going to be 6 into 1 by 3. This angle will check. Okay, so the angle between the side upon the total angle, and then for getting effective number, so if in case of hexagonal there are 6 atoms, so we'll multiply 6 with 1 by 3, so this is going to be 2. So effective number for hexagonal hexagonal structure is 2. Okay, so this chart is very important, guys. So you may be asked questions. Okay, you can ask questions from here. Okay, so this is the case of 2D lattice. Okay, crystal structure, brevis lattice, and condition. We will also study the crystal structure, brevis lattice in 3D lattice. Okay, in 3D in 3D. Okay. Okay, so this is about the effective number of atom, right? In case of hexagon. Now next is a question. We are going to solve question. Okay, question is, so we are going to find atomic fraction. Okay, so there's a question. I think We'll solve this question later. Okay, I'm going to solve it also. It's okay. So question is, a flat surface, a flat surface is covered with non-overlapping non-overlapping gases. I think this question will do in last, because before that I'll explain atomic fraction and those things. Okay. Okay guys, just give me 1 second. Okay, there is technical error. Just give me 1 minute. Okay guys, so there is some technical issue, right? So due to that I'm going to end the class. Okay, so remaining will start in next lecture guys. Okay. Okay guys, so meanwhile also I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. So there's a technical issue guys, so that's why I'm going to end the class. So remaining part we are okay guys. Thank you. Bye now.